Okay, hi everybody. Today what we're going to do is go over single replacement reactions. We're going to talk about how to finish a single replacement equation and how to predict whether that reaction is going to occur or not, because not all chemical reactions actually go forward. So first off, what is a single replacement reaction? We've been talking a lot about types of reactions lately. In a single replacement reaction, you have an element and a compound. Every once in a while you could get two compounds, but most of the time it's going to be an element and a compound. And on the other side of the equation, you are going to get an element and a compound. What's happening is that similar elements replace each other, which means that they trade places. So in the compound, one of the elements is trading places with the element that's by itself. Okay? So in a lot of reactions, the element at the beginning of the equation on the reactant side is a metal. And it's going to replace the metal in the compound. The metal in the compound and the metal element are going to trade places. They are going to replace each other. Okay? So for example, if I had silver, chloride. So there's my compound. I have silver chloride. And I put a piece of potassium in there. That's the element. The two metals would switch places, and so potassium would bond to chlorine, and silver would be left by itself. So the two metals simply swap places. Now everything in this example equation had a charge of 1. So silver's +1, chlorine is -1, and potassium, when it bonds, is +1. So you notice that there's no subscripts in that example. Sometimes there will be. We'll have some of those at the end. Okay? There are instances in which nonmetals replace nonmetals. Okay, so an example of that would be, let's say that I had silver bromide, and to that we add chlorine, which is a diatomic element. Remember your diatomic elements. The two nonmetals would switch places. Chlorine also has a charge of -1 when it bonds, so I would get silver chloride. And bromine would be the element by itself, and it is also a diatomic. Now notice that this equation is not balanced, so I would have to go through here and put coefficients to balance the equation after all the formulas have been written. Okay, so listen, will all single replacement reactions occur? The answer is no. More active or reactive metals, which means that they're less stable on their own, they are going to want to be in the compound. Since they're not stable on their own, they need to bond with something in order to get stability. Okay? Now, less active or reactive elements are more stable, and so they're perfectly fine being elements. They don't necessarily need to be in the compound. Okay? A list of elements in order of their activity is called an activity series. Now you have an activity series on your periodic table. On the back of your periodic table, you have a list of elements in order of activity. Now the most active element is going to be at the top, and these are metals, all except for hydrogen, which bonds like a metal in that it's a cation, it's positive. So lithium would be the most active metal, which is no surprise. It is at the top of the alkali metal family. In fact, most of these up at the top are alkali or alkaline earth metals, which are the most active or reactive elements on the periodic table. Now, as we go down towards the bottom of this list, you start to see some transition metals. And then down at the bottom are some pretty familiar elements. If we look down, the least reactive elements on the periodic table are silver, platinum, and gold, which makes sense, doesn't it? You would not want a reactive metal on your skin. So the least reactive elements are going to be the ones that make up jewelry. Silver, platinum, and gold are not going to react with your skin. They're perfectly fine being elements and sitting on your finger, okay? Things like nickel, however, or copper are going to be more reactive, and those are going to be the types of jewelry that might turn your skin green because there's actually a chemical reaction happening there, okay? Similarly, the halogens on your periodic table make up their own activity series. And it works exactly the same way. Up at the top of the halogen family, which is group 7A on your periodic table, remember that noble gases don't bond. So yes, I'm writing over here, but I'm not referring to the noble gases. The most reactive or most active nonmetal is going to be fluorine. And then the least is going to be astatine. So astatine is perfectly functional as an element on its own. However, fluorine, most of the time, is going to be found in a compound because it's not so stable by itself. Okay. So how do we predict whether or not a reaction is going to go forward and what the products of that reaction are going to be as far as single replacement reactions are concerned? So what you have to do is you have to compare the similar elements in the reactants. So for example, if you're looking at your compound and your element and you notice that the element is a metal, compare that to the metal in the compound. Look at both of those things on your activity series. Similarly, if you notice that the element is a nonmetal, then go ahead and compare that to the nonmetal in the compound. Okay, so look at the element and compare it to the similar element in the compound. Okay. Okay, so if the more reactive element is alone, so if that's the actual element, not in the compound, but if the more reactive element is the element, then the reaction goes forward. So you need to go ahead and swap it with the similar element in the compound and write your equation. Okay? However, if the more reactive element is already in the compound where it's the most stable, then no reaction is going to occur. The elements are exactly where they want to be. The more reactive element is bonded and stabilized, and the less reactive element is a stable element on its own. So no reaction is going to occur. Go ahead and just write NR after the arrow, indicating that there's no reaction, there's not going to be any products. Okay? So here we have some examples that I'll do with you, and you guys can see how all of this works. Okay, so the first reaction, I'm given chlorine gas and sodium bromide. Okay, now chlorine is a nonmetal, so I'm going to compare that to the nonmetal in the compound, bromine. If I look, chlorine is above bromine in the periodic table, so the more reactive element is actually the element. So since this is the least stable element, the more reactive element, and wants to be in the compound, this reaction is going to go forward. Okay, which means I'm going to switch places with bromide. So I'm going to end up getting, and if I look at charges, sodium is +1, chlorine will be -1 when it bonds. So the formula is going to be sodium chloride. And then bromine is going to be left as an element. It's a diatomic element, so I'm going to put Br2. Now if I look at it, this equation is not balanced. The formulas are written correctly based on charge, but it is not balanced. I don't have the same number of atoms on both sides. in order to balance the equation, I have to put a 2 here and a 2 there. So when the more reactive element, when the element towards the top of your activity series is the element, the reaction goes forward. Okay? Now if I look at the next example, bromine is again a nonmetal, so I'm going to compare it to the nonmetal in the compound fluorine. Bromine is below fluorine in this activity series. Fluorine is the one that's less stable, so it's going to want to be in the compound, and it already is. So since everything is the way that it wants to be, it needs to be in order to be stable, put NR. No reaction is going to occur here. If I actually put bromine in potassium fluoride, nothing would happen. Okay, for the next one, I have gold and sodium chloride. Now gold is a metal, so I'm going to compare it to the metal in the compound sodium chloride. So I'm comparing it to sodium. Now sodium is towards the top because it's an alkali metal, and gold is the bottom. Okay, it's the least reactive element, which is why it's so good at forming jewelry. So since sodium is more stable as a compound and gold is not reactive and it's going to stay stable as an element, again, no reaction occurs. In the next one, I look at lithium. Lithium's a metal, so let me compare it to copper on this activity series. Lithium is the top, it's the most reactive element, and copper is almost towards the bottom. So since lithium is the more reactive metal, it's not stable on its own, it's going to want to bond, it's going to want to swap places with copper and form a bond to chlorine. Now lithium has a charge of +1 and chlorine is -1. So the formula for lithium chloride is LiCl. That means copper is going to be left by itself. Copper is not a diatomic, none of the metals are, so it's just Cu. Now I see that this is not balanced for the number of atoms. There are 2 chlorines here, but only 1 here. So I have to put a 2 here, and when I do that, I double lithium, so I have to put a 2 here. So really what you have to do is compare the similar elements in the reactants. If the one at the top of the list is the element on its own, reaction goes forward. If the one higher up on the list is already in the compound, then there's not going to be a reaction. And I hope this explains how to write single replacement reactions.